Hello students, welcome to the lecture on Internet Architecture, and after this lecture we will be able to learn the following objectives. Understand about protocol layering, discuss about network, understand the IP multicasting, explain the unnumbered clients and networks prefaces, discuss the architectural assumption, explain addressing architecture. In the 30 years since its inception, the Internet has experienced remarkable growth. What started in the 1970s as an experimental network connecting research and military networks has become a global network linking more than 1.6 billion users worldwide. The Internet's growth has been fueled by an unprecedented amount of innovation. Over the years, network engineers have developed numerous new physical networking technologies over which the Internet can run. Architecture refers to the current IP protocol, or more generally, any globally agreed upon convention that dictates how packets are handled. The Internet's growing size is transitioned from a research network operated by public entities to a commercial network operated by commercial providers who need to make profits, and is transitioned from a network connecting a small community of users who trust one another to a global network with users who do not know one another and may even intend to harm one another, put pressure on the Internet's technical foundation. Let us now discuss protocol layering. Protocol layering is a common technique to simplify design by dividing them into functional layers, each concerned primarily with one task. While the terminology derives from networking design, it can be broadly applied to general system designs dealing with data acquisition and delivery. Protocol layering should not be confused with top-down design technique. Successive layers do not necessarily address more elemental or primitive concept. Taken together, these protocol layers make up the communication protocol stack. There are several general things about layer protocol stacks that are often misunderstood by people not in the business of setting up communication system between computers. The most common example of a protocol stack in use today is the Internet Protocol Stack. It is generally said to have 4 layers, but if one tried to identify all of the components that exist in the Internet Protocol, we'll find dozens of protocols, not just 4. This model contains layers as follows: the process layer, implemented user level function such as mail delivery, file transfer and remote login. Typical implementation was Telnet, FTP and SMTP programs provided by different vendors with different nonces, but interchangeable as far as the rest of the protocol stack was concerned. The host-to-host layer handled connection establishment, flow control, restrain missions of lost data. Typical program implementation here is TCP and UDP. The Internet layer formatted data for delivery across a number of different physical networks. Now let's discuss network. Computer network is a pivotal element of electronic commerce. The availability of the Internet fueled the growth of commerce for both consumer market and business market. Networks can be categorized in local area networks, LANs, and wide area networks, WANs. The Internet is the world's largest public WAN. Today's networks are built using standard hardware and software components. The communication over the networks are governed by various protocols. TCP or IP protocol is the foundation of all Internet applications such as FTP, email and HTTP. Network security for e-commerce system. Network security refers to the security of operating systems and servers. Hackers can gain portions of control over the operating system or servers by exploring flaws in operating system and server software. Software vendors usually respond to security holes quickly in patches. Firewall. Firewall software restricts access by network protocols and IP addresses. For web application, the typical firewall configuration is to place public web server outside the firewall and rest of servers such as database, email server, FTP and etc. Inside the firewall, and configure the firewall to allow only HTTP access for incoming requests. Virtual private network, VPN. For geographical dispersed organizations who do not want to use expensive private networks, they can use encryption technology and software to create a virtual private network, VPN. Network traffic is encrypted while traveling through the Internet. Private network. The physical network that carries network traffic is not part of the internet. This option offers additional security with extra cost. Internet network architecture. In the field of computer networking, there are different types of technologies that are used for the sake of information, which is used for the sake of the benefit of the humanity. One of these technologies is the internet technology. It is that type of technology that is required to search any kind of information at any place. Internet technology operates with the help of networks such as wired networks and wireless networks. But if one compares the wired technology with the wireless technology, then wired internet technology has more reliable and faster networking as compared to wireless internet technology. The process of assembling the part of the computer, hardware and computer networking is called as computer architecture. Some important parts that are used to configure the networking of the internet technology are as follows. Satellite. A major part of the internet network architecture is the satellite. Satellite plays a vital role in catching and distributing the signals over the network, and the user uses the internet network to search different types of information at any time. Network adapters. There are different types of network adapters that are used to configure or set up the internet technology on one's operating system. First, install the network adapters in the system, then install its software for the sake of its proper working or compatibility. Some common network adapters that are used for access of the internet are LAN cards or modems, etc. Routers. And this technology is also operate wirelessly, so some components that are used to configure the internet network technology wireless router plays an important role and is also the main part of the architecture. It is defined as a device that is used to transmit data from one place to another in the form of packets that are called as data packets. It's known as router. These data packets are also called datagram. Access points AP. A special type of routing device that is used to transmit the data between wired and wireless networking devices called as AP. Clients. Any kind of device such as personal computers, notebooks or any kind of mobile devices which are interlinked with wireless network area referred as a client of internet network architecture. Bridges. A special type of connectors which is used to establish connections between wired network services or devices such as Ethernet and different wireless networks such as wireless LAN. It is called as bridge. It acts as a point of control in internet network architecture. Two components also sometimes play an important role in internet network architecture. Number one, basic service set BSS. Number two, extended service set ESS. Routers. A router is a computer networking device that forwards data packets toward their destination through a process known as routing. Routing occurs at layer 3 of the OSI 7-layer model. Functionality of router. A router must be connected to at least 2 networks or it will have nothing to route. A special variety of router is a one-arm router used to route packets in a virtual LAN environment. Autonomous system. An autonomous system AS is a network or a collection of networks that are all managed and supervised by a single entity or organization. An AS is a heterogeneous network typically governed by a large enterprise. An AS has many different sub-networks with combined routing logic and common routing policies. Autonomous system numbers. Autonomous system numbers ASNs are globally unique numbers that are used to identify autonomous system ASES and which enable an AS to exchange exterior routing information between neighboring ASES.
Networking is the word people use when they're talking about connecting computers together so they can share data with each other and all connect to the internet at the same time. Let's take a closer look at the key components that make up a simple, easy to set up network. Think of a network as something similar to your body's central nervous system. At the top of the network is a brain that handles all the traffic coming through. This is called a router. The brain is connected to a spine that sends signals throughout your network. This device is called a switch, and it distributes signals to all of your computers and devices via network cables. Now let's check out each of the components of a wired network in more detail. We'll start with the router. A router has a smart little computer inside that identifies all of the computers and devices on your network and assigns a unique number to each one. Techie people call this an IP address. A router also connects to the internet outside your home via a modem that can be provided by your DSL or cable internet provider. A router is always at work, managing the tons and tons of information your computers and devices send and receive, and controlling which computers and devices get what information and when. So how does a router actually send information from the internet to your computers and devices? And how does it enable your computers to share information with each other? The answer lies with that device we mentioned earlier, a switch. A switch sends traffic through your network to the places it needs to go. Every Netgear home router has a switch with 4 ports built right into it. You can also get wireless routers from Netgear that use radio signals to do the same thing as a switch. But these still have those 4 ports built into them, so you can use wires with them too. When you're buying a router for use in a wired network, pay attention to the speed of the built-in switch. The fastest switches are called gigabit, and they're perfect for applications like streaming video in your home. Meanwhile, routers with switches called fast Ethernet are great for essential tasks like web surfing, email, and online gaming. Now say you have more than 4 items you'd like to plug into a router. You need more ports. The solution is easy. You'll need an additional switch, which again is that thing that's already built into your router. In this case, though, you just need the switch portion and not another router, because your network doesn't need 2 brains after all. Netgear has switches with as few as 5 ports, as well as some that feature 24 ports or more. Once again, if you need the fastest speeds, go for a gigabit switch. Your Smarty Pants Netgear router will recognize these new connections and start sending data to them right away. Here's one more thing to keep in mind. Some people often confuse a switch with a related device called a hub, which is obsolete. You just need to know that hubs were replaced by switches because switches do the same thing, but with a lot more speed and smarts. A router, a switch, and network cables all come together to create a fast and reliable wired network that works a lot like your body's nervous system. Fortunately, you don't have to be super brainy to understand how it all works.
Now let us discuss IP multicasting. Multicasting is similar to broadcasting, but only transmit information to a specific user. It is used to efficiently transmit streaming media and other types of data to multiple users at one time. The simple way to send data to multiple users simultaneously is to transmit individual copies of the data to each other. Multicasts that take place over the internet are known as IP multicasts since they use the internet protocol IP to transmit data. IP multicasts create multicast trees which allow a single transmission to branch out to individual users. These branches are created at internet routers wherever necessary. Multicast in the internet. Some applications require data to be delivered from a sender to multiple receivers. Making multicast delivery efficient in a packet switching network requires a whole set of new protocols and mechanisms at the network layer. First, multicast addresses must be available that can designate a multicast group as the destination of a datagram. Second, there must be mechanisms that allow a host to join and leave a multicast group. Third, there is a need for multicast routing protocols that set up paths called distribution tree from the sender to the 0.2 members of a multicast group. The issues related to setting up multicast distribution trees are referred to as multicast routing. IP multicast involves both hosts and routers. IP multicast addresses. The range of IP multicast addresses 224.0.0.0 to 239.255.255.255 correspond to the Class D addresses in the class-based IP address scheme. These are the addresses that start with 1110. This leaves 28 bits to identify a multicast group. Multicast addresses designate either permanent or transient multicast groups. A permanent multicast group is associated with an IP multicast address that is registered with IANA. Multicast support for emerging internet application. Today, the majority of internet applications rely on point-to-point transmission. Point-to-multipoint transmission has traditionally been limited to local area network application. Reducing network load. Assume that a stock ticker application is required to transmit packets to 100 stations within an organization network. Unicast transmission to the group of stations will require the periodic transmission of 100 packets, where many packets may be required to traverse the same link. Multicast transmission is the ideal solution for this type of application, since it requires only a single packet transmission by the source, which is then replicated at forks in the multicast delivery tree. Resource discovery. Some applications implement multicast group addresses instead of broadcast to transmit packets to group members residing on the same network. Support for data casting applications. Since 1992, the Internet Engineering Task Force (IETF) has conducted a series of audio cast experiments in which live audio and video were multicast from the IETF meeting site to destinations around the world. Data casting takes compressed audio and video signals from the source station and transmit them as a sequence of UDP packets to a group address. Let us now discuss unnumbered lines and network prefixes. Traditionally, each network interface on an IP host or router has its own IP address. This can cause inefficient use of the scarce IP address space, since it forces allocation of an IP network prefix to every point-to-point link. To solve this problem, a number of people have proposed and implemented the concept of unnumbered point-to-point lines. An unnumbered point-to-point lines does not have any network prefix associated with it. Embedded routers. A router may be a standalone computer system dedicated to its IP router functions. Alternatively, it is possible to embed router functions within a host operating system that supports connection to two or more networks. The embedded router feature seems to make building a network easy, but it has a number of hidden pitfalls. If a host has only a single constituent network interface, it should not act as a router. If a host acts as a router, it is subject to the requirement for router contained in this document. When a host executes embedded router code, it becomes part of the internet infrastructure. Thus, errors in software or configuration can hinder communication between other hosts. As a consequence, the host administrator must lose some autonomy. When a host running embedded router code is concurrently used for other services, the operation and maintenance requirements for the two modes of use may conflict. Transparent routers. There are two basic models for interconnecting local area network and wide area or long-haul networks in the Internet. In the first, the local area network is assigned a network prefix and all routers in the Internet must know how to route to that network. In the second, the local area network shares a small part of the address space of the wide area network. Routers that support this second model are called address sharing routers or transparent routers.
Figuring out what kind of Wi-Fi network is right for you and your needs can be a bit confusing. You might have heard such terms as wireless G, wireless N, dual band, and plenty of other funny words and acronyms you don't understand. What does it all mean? To help make sense of things, let's take a closer look at two families, each of which need very different things from a Wi-Fi network. Here's the Smith family. They have a couple of laptops and a desktop. They just want to be able to use email and the internet, but don't care about streaming videos or any other bells and whistles. Their needs would be met with a basic Wi-Fi router that uses something called wireless G. That's all they'll need as long as they only want their wireless signal to cover a small-sized home. Now check out the Jones family. They also have a couple of laptops and a desktop, but they want to use the internet for more than just reading the news and using email. They want to stream videos without jitters or waiting, and they also have an Xbox that little Johnny likes for online gaming. They even want to use their home network to watch DVDs they've stored on their computers, as well as watch them on their TV. The Joneses are going to need more than the basic wireless G router that the Smiths have. They're going to need a wireless N router. When you're choosing a wireless router for your home, you'll need to consider two things. First, wireless G and wireless N both work on the same radio frequency, which is why they're totally compatible. But the big difference between them is that wireless N is up to 15 times faster and has superior range. Range is an important consideration if you're trying to cover a large home or one with heavy building materials such as bricks. Now, to benefit from wireless in, you'll need, for example, a laptop that has wireless in and a router that's wireless in. That makes them able to talk together at the faster speed, even if there's an older, slower wireless G laptop in the room. Second, if you decide that you want a wireless in router, you'll also need to decide if you want a router with 2 radios. What, you might be asking? Why have 2 radios? The answer is that this gives you a router that's ready for now and the future. The routers with 2 radios in them are called dual band because they have both a 2.4 GHz and 5 GHz radio in them. They allow devices such as a laptop with built-in 5 GHz wireless in, or one upgraded to 5 GHz wireless in with an external adapter, to connect on the 5 GHz band, which is the fastest band with the least interference. A dual-band router also allows other laptops and devices to connect to the 2.4 GHz radio. For wireless networking, a dual-band router is the best you can buy. Now you're ready to choose a wireless router for your home. Think about what you want your network to do for you, whether it's basic email and internet or streaming video and future-ready dual-band radios. Wireless G is enough for a lot of people, while wireless N ensures you'll get everything you need out of your network now and in the future.
Router characteristic. An internet router performs the following functions. Conforms to specific internet protocols specified in this document, including the Internet Protocol IP, Internet Control Message Protocol ICMP, and others as necessary. Interfaces to 2 or more packet networks. For each connected network, the router must implement the function required by that network. Receives and forwards internet datagrams. Important issues in this process are buffer management, congestion control, and fairness. Chooses a next hop destination for each IP datagram based on the information in its routing database. Usually supports an interior gateway protocol IGP to carry out distributed routing and reachability algorithms with the other routers in the same autonomous system. In addition, some routers will need to support an exterior gateway protocol EGP to exchange topological information with other autonomous systems. Provides network management and system support facilities including loading, debugging, status reporting, exception reporting, and control. Now we shall talk about architectural assumption. The current internet architecture is based on a set of assumptions about the communication system. The assumptions most relevant to routers are as follows. The internet is a network of networks. Each host is directly connected to some particular network. Its connection to the internet is only conceptual. 2 hosts on the same network communicate with each other using the same set of protocols that they would use to communicate with hosts on distant networks. Routers do not keep connection state information. To improve the robustness of the communication system, routers are designed to be stateless, forwarding each IP packet independently of other packets. All state information required for end-to-end flow control and reliability is implemented in the host, in the transport layer, or in application programs. Future protocol developments may well end up putting some more state into routers. This is especially likely for multicast routing, resource reservation, and flow-based forwarding. Routing complexity should be in the routing. Routing is a complex and difficult problem and ought to be performed by the routers, not the host. The system must tolerate wide network variation. A basic objective of the internet design is to tolerate a wide range of network characteristics. An IP datagram carries 32-bit source and destination addresses, each of which is partitioned into 2 parts, a constituent network prefix and a host number on that network. Classical IP addressing architecture. Although well documented elsewhere, it is useful to describe the historical use of the network prefix. The language developed to describe it is used in this and other documents and permeates the thinking behind many protocols. Classless interdomain routing (CIDR). The explosive growth of the internet has forced a review of address assignment policies. The traditional uses of general purpose class A, B, and C networks have been modified to achieve better use of IP's 32-bit address space. Classless interdomain routing (CIDR) is a method currently being deployed in the internet backbones to achieve this added efficiency. CIDR depends on deploying and routing to arbitrarily sized networks. By definition, CIDR comprises three elements. Number one, topologically significant address assignment. Number two, routing protocols that are capable of aggregating networks layer reachability information. And number three, consistent forwarding algorithm, longest match. Now in the end, let us summarize what we have learned in this lecture. Architecture refers to the current IP protocol, or more generally any globally agreed upon convention that dictates how packets are handled. The communications over the networks are governed by various protocols. TCP or IP protocol is the foundation of all internet applications such as FTP, email and HTTP. Satellite plays a vital role in catching and distributing the signals over the networks, and the user uses the internet network to search different types of information at any time. A special type of connectors which is used to establish connection between wired network devices such as Ethernet and different wireless networks such as wireless LAN. It is called as bridge. Multicasting enables a single transmission to be split up among multiple users, significantly reducing the required bandwidth.